Today we're going to take a look at section 1.7, which is represent functions as rules and tables. When we're talking about functions, functions have what we call inputs and outputs. So when you plug in a number, you get an answer out. The inputs, or the x values, are always called the domain. The outputs, or what you get as your answer, is called the range, and those are your y values. So the first thing that we're going to do is we're going to look at this table. In it, we have 0, 1, 2, and 4 as our x values. We have 5, 2, 2, and 1 as our y values. What we want to do is we want to identify what the domain is and what the range is. So when we do this, we usually put them in brackets. If you can't make really curly ones, that's okay. And we're going to list them in order from least to greatest. So remember, the domain again is our x values. So I'm just going to list all our x values. We have 0, 1, 2, and 4. Then I'm going to go ahead and I'm going to list my range. And my range are the y values. So again, I'm putting them in order from least to greatest. I have 2 2s, but I'm only going to write it once. And that's identifying the domain and the range. So when we're looking at functions, we're going to be able to tell if something is a function. And functions, for every input, there's one output. Or an easier way to look at that is every x value matches with only one y value. And there are 3 ways that we're going to take a look at this. We're going to look at 2 in this section, and we're going to look at 1 in the next section. So the first way that we're going to look at this is what we call a mapping. And for those of you who are really visual learners, this is going to be a good way to tell if something is a function or not. Okay, so what's going to happen is you're going to have these little bubbles. If they have you make a mapping, then you're going to go ahead and you're going to draw little bubbles and you're going to fill them in with the values that they give you. So for example, if our x values are 1, 2, and 3, and our y values are 4 and 5. A mapping, what that does is has arrows that are drawn. So we might say that 1 matches with 4, 2 matches with 4, and 3 matches with 5. If there's only one arrow coming out of each x value, then it is a function. And in this case, there is only one line coming out of each x value. And so this is a function. It doesn't matter how many lines go to the y value. We're concerned about the x values. Here's another example. So if I have something like this, and let's say that our values are 0, 5, and 2, and we have 2, 3, 4, 5 in here. We'll say 0 matches up with 2, and 0 matches up with 3, 5 matches up with 4, 2 matches up with 5. If you look, coming out of the 0, there are 2 lines coming out of the 0, or 2 arrows coming out of the 0, and for that reason, this is not a function. Now we're going to take a look at determining if something is a function from either a table or ordered pairs. So, for example, they're going to give you something like 0, 1, 4, 6. We have 12, 8, 2, 0. So what I want to do is I want to look at the x values. The x values are really what I care about. So these are all different. So all the x's are different. When all the x values are different, it's automatically a function. Okay, so the next one that we are going to take a look at is 2, 3, 4, 2, 4, 6, 5, 4. Okay, so again, I want to look at my x values. I'm starting off there. If you notice, this one and this one have the same x values. That's when I want to look at the corresponding y values. So this 2 is matched up with 4, and so is the bottom one. So because they're matched up with the same one, it's still a function. It's a function because 2, 4 is the same ordered pair. Okay, so then we're going to take a look at one more. So if I look at this, I'm going to have 5, 4. I'm going to have 5, 5. We're going to have 6, 8. And we have 7, 9. So in this one, if I take a look at this, again, I'm looking at this column to start off with. I have these 5s that are the same. If you notice, their y values right here are different. So because these are different, this is not a function. So always look to your x values first, then look at the corresponding y values. All right, so the next thing we're going to do is we're going to take a look at some ordered pairs, and we're going to be able to tell if this is a function or not. So again, we're going to do the same thing that we did when they were looking at tables. We're going to look at the x values of our ordered pairs. So in this first example, all my x values are different, so this one is automatically a function. Then let's go ahead and take a look at our next one. I'm going to look to see if any of my x values are the same. If you notice, all the y values are the same, but each x value here is different. And so for that reason, this is also a function. We don't care if all the y values are the same. It's the x values that we're concerned about. Looking at this one, if you notice, I have a 4 here and I have a 4 here. So now what I want to do is I want to look at the corresponding y values. Because these are different, it means they're different ordered pairs with the same x value. So this is not a function. The next thing I want to do is I'm going to take a look at this one. So this one again, I have 2 ordered pairs that have 1 as my x value. But if you notice, the y values are the same, which means it's the same point, which says that's okay, so this is still a function. Okay, the next thing, going back to talking about domain and range, is that we can make a table if they tell us the domain. So basically we're going to be finding the range. They told us the equation and they told you what numbers to plug in. So you can go ahead, you can make a table. You can make your table going horizontally or vertically. I don't care. It doesn't matter to me, whichever works best for you. I'm going to do it this way just because I'm going to write out my work on the side so that way you can see where I'm getting these numbers from. So all I'm doing right now is I'm plugging in the values that they told us were part of the domain. Remember, the domain again are my x values. So now what I want to do is I want to plug each one of these in for x and solve. I'm going to write the work on the side. I don't need to see this, but if it helps you, go ahead and write that out. So 2 times 0 is 0. 2 times 2 is 4. 2 times 5 is 10. 2 times 7 is 14. 2 times 8 is 16. So now we've completed the tables. If they wanted us to identify what the range was, then again, we would go back to those brackets that we did, and we would go ahead and we would write 0, 4, 10, 14, and 16. The very last thing in here is going to ask you to write the function rule. All right, so what we want to do is we want to write the function rule. So they're going to give you a table of values already. And then we're going to go ahead and we're going to find the function rule. So basically what we're going to say is, what do we do to the x value to get to the y? So I can say, okay, what do I do to get from 0 to 2? I add 2. Does that hold true for the rest of the table? 1 plus 2 is 3. 4 plus 2 is 6, 6 plus 2 is 8, 10 plus 2 is 12. Yes, it does work. So my function rule then is y equals x plus 2. And here's our last one. So they're going to give you 0, 0, 1, 15, 2, 30, 3, 45. So I want to say, okay, what do I do to get from 0 to 0? Well, I can multiply by anything, so that doesn't really help me. But let's look at to get from 1 to 15. So to get from 1 to 15, I could add 14, but that doesn't work for 0, 0. But I could also multiply by 15. So let's see. 2 times 15 is 30. 3 times 15 is 45. So my function rule is y equals 15 times x.